Mhm.
And I know this isn't super exciting, but it's a skill you'll see. There will be some sort of absolute value on SAT, ACT type stuff. So you set it equal to the positive, equal to the negative. Okay. And this is where I can help you save a little bit of time. You're gonna add 7 to both sides, but because this is a fraction on the right, you really want to add the fraction with the same denominator, 49 over 7. And then you also want to do it simultaneously. You want to do them at the same time. Your brain, wants to do things, wants to repeat things. So it's negative 2x equals 57 over 7. Negative 2x equals 41 over 7. And then normally you divide by negative 2, but because it's a fraction on the right, it's probably better to multiply by negative 1/2.
Mhm.
And so you get x equals negative 57 over 14. Same thing over here on the right. So x equals negative 41 over 14. Like I mentioned, there's 2 of them. There could be 1, there could be 0, but I believe this is the one that it's looking for here on the right. So again, there's no one step that you don't know how to do. You know how to do a transformation. You know how to set a function equal to 0. You know how to do the absolute values, but kind of doing them all together, that's the key, and that's what makes these tests kind of challenging. So let's just have you start with something like this. Minus 3x minus 8 equals 4/5. And again, there's two possibilities here. You set the absolute value equal to it as is, and then you set the absolute value part inside the absolute value equal to the negative of it. Okay. And this time you're going to add 8 to both sides, but you really want to look at this. Okay, it's really 8 over 1. And I've got a 5 here. So what am I going to add to the other side? It's 8 times 5, 40 over 5. 40 over 5, because that reduces to 8. So this is the key. Can you quickly figure out what that is? And that will help you to save time on these things. So you got negative 3x equals 44 over 5. Negative 3x equals 36 over 5. And again, okay, you can divide by negative 3, but then you got fractions. And that's usually not a good idea. So and again, this is different than like classroom math. You have to look for the faster way of doing it. So you multiply by negative 1/3, negative 44 over 15. Same thing over here. Notice there's a repetition of steps on both sides. That's why you really want to do them together. You don't want to go all the way down this one and then do that. So this is negative 36 over 15, but you probably saw that the 36 and the 3 cancel. So this really becomes negative 12 over 5. Is there anything in this part of the question, because this is where I want to start with you, is there anything in this part of the question that you feel like is not, you don't understand or is unclear? Because I'd like you to try just this part of the question in another problem.
Could you go over, I think, the part on the other side? So I understand that you got 36 over 5, and then
Yes.
I think what's confusing is then the negative 1/3 and then times negative 3x. I think that part gets a little confusing.
Okay. So let's just look at that here for a moment. So let's say it's negative 4x equals 5/9. Okay. You could divide by negative 4.
Mm-hmm.
Okay. And on the left, it's x. Great. But on the right, it's like, well, what is this? And we did this last time. We didn't necessarily cover this one, but this number goes right up here. It becomes 5 over negative 36. But I'm not sure that that is clear. So that's why my preference, and it's when you have a fraction on the right hand side, when the right hand side is this fraction, you want to multiply by negative 1/4, because that's what clears the negative 4. And a fraction times a fraction is easier than dividing by a number, because you multiply across. negative
Mhm.
5 over 36. Okay, so it's like both get to the same answer, but like there's times when one is better than the other. And it's not necessarily you want to remember the rules, you just want to kind of move forward and be like, all right, well, if I divide, I got to know what to do there. But if I multiply, I know what to do there with the fraction. So let's have you try one here. Let's have you try negative 3x equals 7/6. And go ahead and solve that for x, please.
Negative 7/18.
Yes, negative 7 over 18. Now, what could happen, and that I'll do that in this one, is let's say it's negative 2x equals 10/7. This time you get a reduction. You have a fraction that you have to reduce. So give that a try, please.
Negative 5/7.
Yes, x is negative 5/7. Very good. Okay, so let's back up here to the absolute value part. So the absolute value of like minus 3x minus 4 equals 3/2. Okay.
Okay.
Whenever you have an absolute value equaling something, okay, it always produces two situations. And the reason there's two situations is because it hits twice potentially.
Mm-hmm.
Okay, and that's why you do this. You just apply the definition. And so you have negative 3x minus 4 equals positive 3/2. Negative 3x minus 4 equals negative 3/2. And then this is where you can save some time. So you're going to add 4 to both sides of the equation, but because it's a fraction, you don't want to add 4 to 3/2. You've got to look at it as, okay, I need to make a common denominator. So it's obviously 2. So if you multiply the 4 by 2, you get 8. The 1 by 2, you get 2. So you're really adding 8/2 to both sides of the equation. And that's an important skill here, to be able to quickly do that, be able to quickly get that new fraction. So it's negative 3x equals 11/2. 3 plus 8 is 11. Negative 3x equals 5/2, like that. And so if you could solve each of these for x doing the same thing we just did. How are you doing on these?
So for the first one, the negative 3x equals 11 over 2, I got -1, or I got negative 11 over 6, which is -1 5/6.
Yeah, this is okay. You want to leave it as an
Okay.
improper fraction. Yeah, that's the best
Okay.
way. Okay, and let me know when you get the next one.
The next one is -5/6.
Yes, very good. Okay, so let's see if you can do one or maybe talk me through the steps here. Okay. What is the first thing to do when you're solving this absolute value equation?
Don't you like take it out of the absolute value?
Yes, you have to write the two cases. You have to say, okay, it's equal to it exactly as is,
Oh, okay.
and then it's equal to the negative of it. So these are exactly the same, except one's positive and one's negative. Now, one of the nice things about scenarios tests is they don't tend to have like a
Okay.
lot of exceptions. Like you don't have, it's not like this would ever be a negative 1/3, which is no solution. They tend to be more about like, can you synthesize steps? So the next thing here is you're going to add 4 to both sides, but
Okay.
this is a fraction. So what do we want the common denominator to be? Not sure if you heard me, but we want the common denominator to be between 1 and 3 to be 3. So you really want to rewrite 4 as 12/3. And if again, how am I getting that number? I'm always taking this number to multiplying that, and I'm multiplying that. It just that's
Okay.
it's always that way. And so over here, I'm doing the same thing. I'm going to add 12/3. It looks a little awkward. I know you want to write +4, but it doesn't help you because you got, then you're writing, well, it's 4 minus 1/3. And then you're writing, what is that? And then you're doing a lot of extra writing to get
Yeah.
to the same answer. So this is 2x equals 13/3, 2x equals 11/3. Will you solve it from here and give me the two x values, please?
Okay. 13 over 6 and 11 over 6.
Yes, perfect. Okay, so let's see if you can do a bit more on this. Okay, so here we go. Absolute value minus 4x minus 8 equals 1/7. What is the first step to solving this?
Okay. So okay.
So you gotta write the two equations. What's the first equation, if you remember?
Oh, okay. So the first equation would be -4x minus 8 equals 1/7.
Good. And the other?
Um, and then the second one would be -4 minus 8 equals -1/7.
It's exactly the same. It's the -4x minus 8, but it's equal to -1/7. So it's one's
Yeah.
positive, one's negative. Okay. And
Okay.
I know I've chosen some more difficult numbers than maybe you would, but there's important skills here that can't emphasize enough. So you're going to add 8 to both sides, but what are you adding so that you have the same fraction? And you take this 7 and you multiply by each of these numbers.
Is it 56 over 7?
Yes. So that's -4x equals 57 over 7. negative 4x equals 55 over 7. And then from here, you divide by negative 4, but you can also multiply by negative 1/4, which I think would be preferred here. So that's negative 57 over 28. Do the same thing here. Negative 55 over 28. Okay, now we have not done one where you have to subtract, but might as well bring that up here now. So absolute value 8x plus 6 equals 7/9. What are the two equations?
Okay. So the first equation would be 8x plus 6 equals 7/9.
Okay, and the other one?
So for the negative one, would it stay the same, but it's negative 7/9?
Yes, exactly.
Okay.
Exactly. And that's something you maybe haven't like seen in a while, but whenever you have an equality like this, it's always the case. So so now you subtract 6 from both sides. We've been doing a lot, all the problems have been plus, but it's the same thing. You just subtract 6. It's 6 over 1. So you take this 9, combine it with that, each of the numerator and the denominator. So you're going to subtract 54 over 9. And you're going to subtract 54 over 9 here. We've done a lot of adding. Now you have to subtract. Okay, so that's 8x equals, and this, subtraction, like I was working with a student earlier today, and multiplication and addition are friendly. Division, subtraction, they're just awkward. But when you subtract, you've got to get comfortable with this, being able to do it quickly. You get the two negatives here. Okay. So again, you multiply by 1/8, 1/8. So it's negative 47 over 72. X equals negative 61 over 72.
Okay.
So like if you were given this problem in a standardized test, you wouldn't get the fractions, but you've got to know how to do fractions because there will be a problem where you'll get some fractions. So that's why we're doing it like this over and over. So let me have you try this one and see if you can do it start to finish on your own, just the absolute value part, and then we'll talk about the rest of it. So I have absolute value 6x plus 1 equals 3/4. Take a few minutes and see if you can solve that on your own, please. How are you doing on this one?
I got negative 1/24 and negative 7/24.
That is correct. Very good. So again, there's no one, I mean, you know how to do all the little pieces or maybe a little review, but you know, we'll you just want to get to be able to do some of these standardized test problems. You got to be able to like merge a bunch of things that you know. So let's talk a little bit more about absolute value, and we're going to start with graphing. If you remember, a quadratic has this form right here. H and K is the vertex. And so an example would be like, it'd be 2 times x minus 3 squared plus 5. The vertex is 3 comma 5. Notice if it's minus inside here, it just takes on that value. If it's plus inside here, it's the negative of that. And this number out in front, this a, the a tells you whether it opens up or down. So a is 2, and because it's positive, it opens up. So why do we care about that? Because if we're going to make a really quick sketch of this thing, 3, 5, let's say that's 3, 5. We know that it opens up. Does this have any x-intercepts? Does it cross the x-axis?
No.
No. Now, similarly, we can do the same thing for absolute value. A absolute value, x minus h, oops, there's no square, sorry about that, plus k. It too has a vertex at h comma k. A greater than 0 means it opens up. A less than 0 means it opens down. So let's actually go back to that original question. See if I can convince you of some things here that to help answer some of these questions. And then we'll talk about some more conceptual stuff. The original problem was something like -7 minus 2x minus 7 plus 9. And there's a bit more that goes on to this, but do you see that well, actually, maybe this isn't a good example. I apologize. Let me change this up a little bit. Let's say it was -3 absolute value x minus 5 plus 9. What is the vertex of this? Hopefully you see it's 5, 9, because it's the x minus h plus k. Now, does it open up or down? And that depends on this number. Does it open up or down? It's less than 0.
So it's -3, so down.
Down, yeah. So a quick sketch, 5 9's here, it opens down. Do you see how it has 2 intercepts?
Yeah.
Okay, that's good. So sometimes you get more conceptual questions, okay? And like a more conceptual question would be like, how many intercepts does this thing have? And if you can quickly sketch it and know that it opens down, you know that the answer, because the answer space would be like 0, 1, 2, something else, right? So having a good visual helps. Now, all I'm doing in the original question is I'm saying, well, what if you shift this thing down or up 1? Does it still have 2 intercepts? Yeah, it does. Okay, so there's actually nothing about this question that's really complicated when you get down to like what the core thing that it wants you to solve for, which is, can you solve an absolute value equation? So let's look at one more of these. Actually, I don't know why it didn't pull that up. Where are my 2 columns? Oh, I already had that open. Okay, sorry, I'm just trying to get one here that we haven't done. Yeah, this one's good. All right. Okay, so here is, sorry, that's so small. Okay, so here's another version of the question of the week. So let me grab the right color here. This. So it says g of x is absolute value 2x plus 4 minus 2. That doesn't look too bad. If h of x equals g of x minus 9, so all we're saying is you'd have to take this function and move it down. But let's think about what the graph of this looks like for a moment. 2x plus 4, okay, minus 3. There's some number that makes this 0. The vertex ends up being -2, -3. And that's over here. And see how this number out in front is 1, it's positive, so it opens up. So moving it down 9, all that does is it doesn't change the fact that it has an intercept. So this is just a distraction. And that's, the more we work together, the more I'm going to show you that a lot of things in these questions are just distractions. They do have to be used, but they're not really critical. I mean, if you can just set this equal to 0 and solve it, you're in good shape. This is just another little wrinkle.
Mm-hmm.
Okay? But in terms of how to actually solve this problem, you do have to take that original absolute value function and subtract 9. And that is your h of x. So absolute value 2x plus 4 minus 12 equals 0. And then you're going to add 12 to both sides. And this is just your standard absolute value function thing. So you write the two equations. You write 2x plus 4 equals 12, and 2x plus 4 equals -12. So go ahead and solve this from here, please, and tell me what the x-intercepts are.
X equals 4 and x equals -8.
Yep. Sometimes one's positive and one's negative. Sometimes they're both negative, both positive. That depends on like how it's scaled. It really could be the case that they're, you get one of each. Lots of possibilities. So yeah. Right. Okay, let me have you try one more and we'll move on to a new topic. So we can get this one down. I'll have you try this from start to finish. I think the numbers are somewhat reasonable to work through. So I'll let you take it from here. How are you doing on this one?
I got 13/9 and -1/9.
Okay, got one there. Perfect. So that's another point, like you may or may not see both answers. So this could be a free response question where it said, determine an x-intercept, and there's actually two answers that you could give. You would just pick one that you felt was, correct for you. So
Okay.
good. I'm glad we're able to kind of tackle this topic and get through a lot of detail on it. Let's see what else we can do here. So let's talk about the following. So let's say I give you a function. I tell you f of x equals x squared, and then I want you to find f of x plus 2. That means you take whatever your input is and you replace it where there's an x. Okay, so from here you have to expand, and you want to be careful here. You want to write it as x plus 2 times x plus 2 and then FOIL. So this becomes x squared plus 4x plus 4. Okay. And I think you've seen this before, but this is just a little bit of review. So if that was clear, imagine I give you something like this. I say, okay, f of x equals 4 minus x squared. What is f of x plus 1? It would be 4 minus, wherever you see an x, replace with x plus 1 squared. And this time, you want to always write it out. And then you have to pretend like there's almost like an extra set of parentheses here. So you first expand the binomials. That's x squared plus 2x plus 1. But then this is really important. You negate everything. So 4 minus x squared minus 2x minus 1. Okay. So why are we doing all this? Because the next type of transformation that you might see. So let's say I give you an absolute value function. I say g of x equals 4, absolute value negative 2x minus 2 minus 5. But I tell you that h of x equals g of x plus 6. So what that means is you have to take this x plus 6 and substitute it in for x. So it's 4 absolute value negative 2 x plus 6 minus 2 minus 5. Okay. And then the parentheses are so super important here. You distribute these things to both. So it's 4 absolute value negative 2x minus 12 minus 2 minus 5. And then you combine like terms. So 4 minus 2x minus 14. Actually, this is still absolute value. Okay. And again, I could ask you to do the same thing. I could have you set this equal to 0. Okay. You would add 5 to both sides. You would divide by 4. So you'd have 5/4 equals absolute value negative 2x minus 14. And this is where it's exactly the same problem that we've been solving. So I'll help you out here. It's negative 2x minus 14 equals 5/4. Negative 2x minus 14 equals negative 5/4. You add 14 to both sides, but because you want that fraction to be 4, you multiply both of these by 4. That's 56/4. 56/4. So you get negative 2x equals 61/4. Negative 2x equals 51/4. And then you multiply by negative 1/2 to clear that fraction. So x equals negative 61/8. X equals negative 51/8. Okay. So the point is that there's other transformations, not just up or down. It could be left or right. If we go back and look at a graph of the absolute value, if the original has two x-intercepts, if you move it up, if you move it left or right, it still has two intercepts. If you move it down, it still has two intercepts. The only way it might change is if it moves up. And like you will see some conceptual questions like that, but we're focusing more on just the analytics, being able to do the multiplication, division, solving the absolute values.
Okay.
Okay, so this is a good place for us to stop. I guess we got a lesson here then on the hour, so we'll pick up with some new stuff, and I'm glad we're able to get this extra session, and I'll see you shortly.
Yeah, thank you.
Welcome. Bye now.
Bye.